Thank you very much, Joe, and also thank you for helping me select the one of 4 title options. The initial title was rather long. Today what I'd like to talk to you about is much in line with some of the things that we have been thinking about already. Traditional textbooks and curriculum in undergraduate and introductory graduate statistics courses consider the primary research questions and consequently analyses of interest as focused on analysis of patterns of means or locations, whether this be in a between group, within group, or in a between within groups data analysis context. Most of the analytic strategies presented in commonly used textbooks deploy parametric data analytic strategies with underlying assumptions of homogeneity of variances or covariances structures for between group univariate or multivariate analysis of variance, or assumptions of sphericity for analyses where at least one factor is a within subjects factor, and treat findings of violations of these assumptions as nuisances. Although such findings are indeed nuisances to what may be the primary analysis of interest, they can also be findings of interest in and of themselves. And I argue, and I think many of you agree, particularly in this room, that an updated pedagogical approach to these topics is advisable. Today's talk is focused on a philosophy and pedagogical strategy that over the years I have been emphasizing increasingly in my teaching, and I believe could and perhaps should be incorporated into teaching materials and textbooks in the area of statistics education and psychology. As quantitative psychologists engaged in the teaching of statistics at the undergraduate and graduate level in our respective programs, 3 of the key things that we cover with our students when we review statistical procedures to address specific research questions are the fundamental assumptions under which the inferential statistical procedures are based, the procedures by means of which to assess the tenability of these assumptions, and the procedures available to address violations of these particular assumptions. These vary, of course, as a function of the specific procedure that we are reviewing with our students or the specific models that we are considering with our students. The approach that I advocate be brought to teaching of statistics and psychology is that the assessment of the tenability of statistical assumptions, again, should not be considered as a nuisance, an annoyance, or an obstacle. Indeed, the assessment of the tenability or violation of an assumption can, in many cases, be framed as a research question of value in and of itself. If we agree that in some circumstances that the assessment of an assumption violation can be framed as a research question of value, it follows then that a violation of fundamentals assumptions is not in some circumstances simply something that needs to be overcome, in the sense that if we obtain an assumption violation, then we simply need to identify the appropriate, robust statistical procedure. Rather, if we obtain an assumption violation, then we may have an opportunity to learn something more about the variables, the groups, the cases, the case under study. It also presents for us the idea that perhaps we could be starting out with a consideration of these types of queries as viable research questions in the first place. But back to the coverage of assumption violations in the literature and in textbooks. Before I go much further, I would like to acknowledge that the idea that finding of assumption violations are informative is not a novel conceptualization. The 1988 Psychological Bulletin paper by Anthony Brick and Stephen Rodenbush, entitled very nicely, I like this one, Heterogeneity of Variance in Experimental Studies, a Challenge to Conventional Interpretations, is exemplary on the topic of between-group differences and variance as informative. The 2000 Journal of Consulting and Clinical Psychology article by Robert Grissom entitled Heterogeneity of Variance in Clinical Data is also exemplary in providing a very clear statement, indeed a section heading stating, in quotes, variance is more than just a nuisance parameter. Regretfully, however, after providing several examples, I'm thinking particularly of the Grissom paper, of between-group heterogeneity of variance, the paper only briefly reviews procedures available to assess homo or heteroscedasticity, states, and I quote here, some applied statisticians de-emphasize tests of homoscedasticity, maintaining that researchers should proceed directly to heteroscedastic methods. Thus, the emphasis again comes down on the side of heteroscedasticity as an obstacle to be overcome. In terms of textbooks, if we think about introductory statistics textbooks, increasingly they provide coverage of statistical procedures, and I would argue that although the variety of statistical procedures has increased, the tenor remains much the same, with the emphasis on variations of assessment of the appropriateness of variations of some form of a linear model. When Joe was talking about textbooks earlier on, the outline of textbooks remains very much the same, just that there's a little bit more detail in each of the chapters that include maybe some robust techniques, if they do that at all. Rand Wilcox, in his classic textbooks, New Statistical Procedures of the Social Sciences, Modern Solutions for Basic Problems, has been instrumental in trying to advance statistics education in the behavioral and social sciences through exposing readers to general as well as alternative data analytic strategies. Other textbooks, such as the more recent edition of a textbook, which I had used last term, Research Design and Statistical Analysis by Myers, Wells, and Lorch, provides an excellent and improved treatment of standard parametric procedures, as well as alternative procedures under assumption violations. Again, however, though there are some improvements in textbooks, I think that much needs to be done in terms of changing our general curriculum. So again, perhaps it is the case that we're providing material highlighting the importance of parameters other than location in our teaching. We need to think about changing our curriculum and our textbooks, particularly since they are the backbones or the supporting structures under which we orient our teaching. I've reviewed that slide already. So this was just sort of recapping the journal articles and textbooks. So what I think is pedagogy needs to be reframed. And so what I'm going to start here is with some basic illustrations highlighting, I think, the importance of looking at our data in different ways. So many of you who know me know I'm particularly interested in how people respond to questionnaires, and a questionnaire I've been focusing on over the recent years is the Center for Epidemiologic Studies Depressive Symptomology Scale. So these are data on the composite CESD scores, theoretical minimum of 0, theoretical maximum of 60. The data were collected here on just over 2,000 undergraduate students at a university in the north of the US Pacific Northwest in Canada. We see a distribution that is definitely not normally distributed. If we break it out into responses as in a histogram, stacked histogram, by category of whether or not English is your first language, we see that the general trend of a positive skew for both groups. Box plot illustrates similarly. If we stack this in terms of responses to an English fluency question, how fluent are you in English? Very fluent in English, English is my first language, or equivalent, that's blue. Green, more fluent in English than my first language, that's green. Taupe, same fluency in English as my first language. Mauve, less fluent in English than my first language. The box plots show, it's a similar trend in the central location of the distributions, but differential tail length. If we go and look at the items, breaking it down, I'm going to show you the distributional form across 3 items, which sort of exemplify different distributional shapes. The items I've selected are: I felt that I was just as good as other people, I felt that people dislike me, I had trouble keeping my mind on what I was doing. So in terms of the item, I felt that I was just as good as other people, I have provided for you the histograms for responses on the 4-point response scale. What we have in the upper left for you are the very fluent in English, upper right and more fluent in English than my first language. In the lower left, same fluency in English as my first language, and on the right, on the lower right, less fluent in English than my first language. So what you see is definite differences in the distributional form as a function of the language fluency. Yes, we can look at location, but looking at other parameters of the distribution, it should also be informative. In terms of, I felt that people dislike me, just to sort of illustrate that distributional form does not necessarily vary as a function of English language fluency, I have provided for you the histograms on that item. Now, in terms of using statistical procedures to evaluate, assess the similarity or dissimilarity of the distributional forms, these 2 items I did select for you as essentially the most extreme examples based on those assessments. You might think, looking at these item examples, that in general you would the pattern is for positive skew. However, if I'll show you an item here, that was item 5. I had trouble keeping my mind on what I was doing. We have rather the non-skewed distribution across the 4 categories of language fluency. So with the CESD example, I've illustrated that there are a variety of distributional forms that we can be thinking about. It's useful to think about something more than just, where the location of the variable. Distributions vary between groups, distributions varied across variables, and some distributions varied not just in terms of the location parameters, but in terms of other parameters. Some other scenarios that I think we can bring to our students to highlight the importance of looking at parameters other than just that of location are in my next few slides. So I have a background also primarily through my consulting collaborative work in what we'll call program evaluation or intervention evaluation. So a lot of the examples that I give in class are around evaluating, looking at examples of comparing interventions. So let's think about an intervention where the goal is to reduce negative behaviors. And if the intervention is successful, we might be shifting from the distribution on the left to the distribution on the right, where perhaps if it were a randomized study, we would have the control group as being what we have on the left and the intervention group, post-intervention, on the right. If it were a within subjects design, what we would have on the left was the pre-intervention and on the right, the post-intervention. Clearly, you know, the goal, if the variable of interest is occurrences of negative behaviors, perhaps, you know, I don't know, self-harm. We want people to be not engaging in self-harm behaviors. Our ideal is that zero self-harm behaviors would be performed, so clearly we want something on the right. Actually, we'd probably want something more extreme than that. So it's not just location, it's other aspects of the distribution. And I think if we highlight these kinds of examples to students, to our colleagues, and we write about them in our textbooks, we can shift this, what I call central location, mean-focused analyses. Again, actually, Pascal Debecq's example earlier on, citing the study where there was the physics education example under the two education principles, we saw a very nice illustration of what we have here. So if the goal is to produce mastery of skill, I'm assuming that we might be starting with something a somewhat normal, at least symmetric distribution to begin, control group, but pre-intervention, post-intervention, we have definitely this negatively skewed distribution. If our intervention is actually to reduce variability, bring scores within an acceptable range, we might see something like this. We're not interested in changing the mean. We actually want to, you know, if on average, you know, people are, you know, have scores like this, but we want to, we've got some people who have low blood pressure that's far too low, blood pressure that's far too high. We want to have an intervention that reduces the variability. We actually might want to design interventions where we actually want to break the association between variables. So that perhaps we want to reduce the association between test anxiety and test performance. Pre-intervention on the left, post-intervention on the right. So we have a variety of statistical data analytic strategies that we can use to look at parameters other than those of central location. We can look, we have We have techniques to examine distributional form, to assess homogeneity, heterogeneity of variances between and within groups, homogeneity and heterogeneity of correlation matrices, and we have these techniques that are viable under different distributional conditions and sample sizes. When the old textbooks were being written, many of those techniques that were being looked at were not viable under the smaller sample size conditions. And so you'll see textbooks that say, oh, you need not test for homogeneity of variance, because that's like looking to sort of see if the sea is calm when you actually have a steamship going through the rough waters. Moving forward, we need to incorporate thinking about parameters other than those of location explicitly in our pedagogy, place the teaching of strategies to assess these other parameters at a higher level of importance, provide students of all levels with resources that are user-friendly to encourage use of these techniques that are not widely available. Because ultimately, until these techniques are made more obvious in their utility to their outcomes addressing fundamental research questions, they will continue to be seen merely as tedious diagnostic strategies to address assumption violations, and findings of assumption violations as nuisances to be overcome. The increased awareness of robust data analytic strategies and incorporation of these techniques in the literature and in textbooks is a clear improvement. However, I really do think we can do better. So that is what I would like to share with you today. Yes, David.
There's an example you might like. It's in Agresti and Finley's book, and it's data from Brian Everett on treatment of anorexia in girls. There are 3 treatment groups.
Yeah.
And in one of the treatment groups, if you plot the data, you can see it's a mixture of 2 kinds of people in the one treatment group, one of which is a group of responders, one of which is a group of non-responders.
Yeah.
It's one that you wouldn't want to transform. You couldn't transform to normality, and there's something really interesting in there.
Exactly. Yeah. So David's comment was regarding an example where there are different people with eating disorders and different treatment, I guess maybe were there treatment conditions for that? And there were responders and non-responders. And actually I had planned to talk about, you know, how in the medical literature we do often look trying to sort of identify responders, non-responders, super responders, really super duper non-responders, because of these different mixtures, and we need to think about that. Not everybody is responding to an intervention in the same way. So here the figures that I depicted for you in the latter part of the talk, I was sort of presuming in some sense that everybody was responding in the same way, but that absolutely need not be the case. And so it really makes it very important to look at the full distributional form. Thank you, David.